Okay, part 2 of section 3.3, retirement plan. If your employer sets aside $100 a month based on your salary at 8% monthly, how much would you have if you continue to work for 35 years? At the end of 35 years, how much money are you going to have? And by the way, the answer is not just 100 times 12 times 35. That's how much money would be invested altogether in the 35-year period. You know, it's $1,200 a year for 35 years. The product is just the amount of money that was put into the retirement plan. But what you'll have after 35 years is a whole lot more than that because of the power of the money to be earning interest. You see that? That's why money is time sensitive. And in this case, you're going to have what, 12 times 35. That's a lot. That means like 400 plus payments going into your account. So what you have to do is to add up a whole bunch of different deposits. Okay. And so you do not want to do this manually. Of course, you have a formula. Let's go ahead and apply that. Let's identify these values first. D is 100. R, the rate is 8% monthly, which means K is 12, and T is 35. Pretty much that's all you need to know. Now notice here, R over K is a pretty ugly number, okay? 0.08 divided by 12. And this turns out to be 0.006666 continuing. Again, do not round this to 0.007 or 0.006. Okay, you have a lot more, and as you do your calculations involving large exponents, your answer would be way off if you do not use a bunch of these things. So it's better if you use the memory key in your calculator, or just write down as many digits as possible. All right. So after 35 years, the formula tells us the amount is going to be D 100 times, and this is the tricky part, right? It's a big fraction, one big fraction. 1 plus 0.08 divided by 12. Raised to the power of what? 35. Let's do 12 because it's KT. 12 times 35. And by the way, 12 times 35, you can calculate this first if you'd like, and then subtract 1 from this. That is your numerator. And then you still have to divide this by 0.006666666 again. Okay, and after you do this, you are going to get your answer. All right, so how do you do that? Let me show you. Okay, 0.08 divided by 12. That's the ugly number. Add 1 to it. All right, inside the parentheses, you have 1.006666 and all of these sixes. Right, now you raise this to the power of, right? So power of, now I don't know what 12 times 35 is, but that's okay. I can use the parentheses. Parentheses open, 12 times 35, parentheses close. And what you see here, 420, that's the number of months in a 35 year period. Okay, so in other words, you would be making $100 payment, or your company is making $100 payment for you in your account 420 times. Okay, and so technically, I mean, you will end up with 42,000 if there's no interest involved. But what I was saying earlier is that you will end up with a lot more than $42,000 on your retirement because the money is being invested for a long time, even for different periods of time. Okay, so that I'm going to put equal. And so that's going to be the numerator, except you have to subtract 1 from it. And this is a significant step. Don't forget that. So 15.29 is roughly the numerator. Now I'm going to divide this by what? 0.08 divided by 12. Now I don't like to enter a bunch of sixes. So here I'm going to use the parentheses again. Parentheses 0.08 divided by 12, because that is my denominator. And that is my denominator. Okay, I am about to divide the numerator by this number. And this is what you get. These numbers really don't make sense in intermediate steps, so don't worry too much about them. Now you multiply this by $100 a month, and here is your answer. Okay, did you get that? $229,388.25. Let's go ahead and write this down. Okay, so I'm going to write down this answer, 229,000. 38825. It's a lot better than you know what you had, like $42,000, right? And this is what people do with their retirement when you're are able to save up some money through a retirement account or through a pension, and so on. Okay, I forgot something on the first page because now I just suddenly realized the question that I was asking at the bottom of the page 1 was actually not this amount, right? I mean, this is how much you will have at the end of the 5-year period. Now, going back there, how much will you have after 5 years? If you save up 100, how much will you have? So that part is okay. This is the answer to that first part of the question. The second part, I did not complete this. How much interest would you earn in a 5-year period? So this is the amount this is the balance you'll have in 5 years. But in 5 years, okay, so you put $100 every month for 5 years, right? So that's $6,000 in payment, all in total payments you made. In other words, you have invested over the 5-year period $6,000, and your balance at the end of the 5-year period turns out to be $6,977. All right. So the interest, the total interest earned, is of course the difference between these. I hope this is making sense. Some of you are money savvy. You may not be good at math, but if you can do your math, your financial calculations, that's a great thing. Okay, so you find the difference between the amount you will end up with and amount you invested over the 5-year span, and that is the interest that the total interest amount that you have earned or you will have earned in the 5-year span. Okay, and you can do the same thing here. If you subtract 4,200? No, sorry, 42,000. This is how much your company is invested in a 35-year period, $100 each for 420 months. And if you find the difference here, that is going to be the total interest earned. And that's going to be significant. You can tell this is like $180,000. And that is the power of compound interest that works for you if you are saving money. Okay, now this is what I was coming to. So let me go ahead and finish this. What if you just put $100 a month under your mattress? Okay, so this is what I was coming to. You put $100 12 times a year, 35 years. Remember, this was 420 months. So you'll end up with 42000 or $42,000. This is how much you will have invested. Okay, so the difference is what is known as the total interest. I'm going to write this again just so you can tell what the answer is. And this is a simple case. It's 187,388.25. This is your total interest earned. A lot more than the amount of money that you put into, or your company put into your retirement account, right? If you ever wonder like why people are paying attention to the stock prices and basically like S&P and New York Stock Exchange or the Dow Jones Industrial Average, because most people don't buy or sell stocks on a daily basis. And that's because most of their retirement accounts are invested into the financial and in the funds and stocks and these investment plans. Okay, and so what happens to the stock market pretty much dictates the rate of return, this R. Okay, and so that's why people are paying attention to the retirement. When I was a student, I had no idea, and so I thought, like who cares about the stock market and how the stock market's doing? The answer is almost everybody does, because for most people, that tells them how much they are going to have in their retirement. Okay, a couple more questions here, sort of intriguing and eye-opening examples I want you to pay attention to. Okay, so the first of those questions is the college fund example. Let's suppose that you want to invest money for your child's college education. I was not able to do this when I was a parent, when I when I had my children, because I was a poor dad, right? But if you can invest some money, or at least set aside some money every month for your child's college education, you are doing your child a great favor. When the child is born, you start saving up money. You want to save up so that your child will have $30,000 in 18 years when your child becomes 18 years of age. If you can invest your money at 6% monthly, how much do you have to invest, set aside every month for 18 years? And that sounds like a daunting task. Like, how can I come up with $30,000 for my 18-year-old to start a college? Okay, well, you notice here, you are not given the amount D, right? The question is, how much do you have to invest every month? So we don't know what the D is, but we do know everything else. So D is the question mark. R is given as 6%. And of course, we assume that because you are investing every, what does it say? Every month. So K is 12. You want your sum after 18 years to be 30,000. Lucky child you have. Hopefully, your child will be at age 18 interested in attending college, because that's what the money is for. And T is 18 years, right? All right, let's go ahead and try this. You want A18 to be, well, let's go ahead and write the formula. We don't know what the D is, okay? But it's 1 plus 0.06 divided by 12. And this is easy. It's 1.005. Raise it to the what? 12 times 18. What is 12 times 18? Okay, that's something you can calculate if you want to do this part first. Subtract 1 from it. Divide this by 0.06 divided by 12. Okay, now again, this is a big chunk that must be calculated first. That is equal to 30,000. Okay, so you see the difference? Up to now, we were given D and we were calculating A, but this time we are given the total amount you want, and you're trying to find what D is. How much do you have to set aside every month? Very practical question. By the way, I'm going to change this to S because we have been using S for the sum of a annuity balance. Well, you can say this is 1.005 raised to, well, I'm just going to go ahead and write down 12 times 18 at this point, minus 1, all divided by 0.005, right? You want this to be 30,000. D times this to be 30,000. Okay. And so I can go ahead and calculate this part, and let's go ahead and do this actually. Okay, so our job is to go, and I'm going to go ahead and do this from the beginning. 0.06 divided by 12. I know what the answer is here. And then plus 1, and that's going to give you what's inside the parentheses. You raise it to the power of, and I have 12 times 18. 12 times 18 happens to be 216. You can jot it down if you like, right? And that's the exponent, and then you subtract 1 from it. This is your numerator. And then you make sure you put the equal sign first, and then you divide it by, remember that was 0.005. Okay, it's R divided by K. In this case, it's 0.06 divided by 12. And that's going to give you everything after the D. Okay, so 387.35 times D is equal to 30,000. So how do you find that D? Okay, all you have to do is to divide 30,000 by this number. All right, so let's go ahead. You can write down this number, and I will give you the answer to this question. Okay, let's do that. So what we are saying is that 387,000, comma, or 0.383194. That's the number that we came up with, right? Let me just check to make sure. Okay, so the answer to that question was 387.3531944 and so on. All right, I'm going to round off to some reasonable point. Okay, so what we are given is that this times D is equal to 30,000. And so to find the deposit that you need to make every month, all you have to do is to divide 30,000 by this number. Okay, and so and it's going to be an approximate number, but you should get 77.45. Okay, so it's $77.45. Now, does this sound too good to be true? I mean, it sort of does, right? Because all this is saying is if you're a new parent and if you want to raise money for your college, your child to attend college in 18 years, if you set aside $77.45 every month, as long as you can get 6% on the compounding monthly compounding interest rate or an investment plan, you will end up with $30,000 in 18 years. So that is a good thing you can do. And it doesn't have to be 77, right? Whatever you can do for your child, that would be tremendous. And of course, you'd rather be a recipient of this. Unfortunately, most of us aren't, but that's okay, all right, so anyway, this is how you can find the deposit, the amount of deposit, if you are interested in finding that. Okay, finally, let's compare the two scenarios. I want you to know, and I want to sort of you to see really, okay, what difference small percentage difference in the APR makes. Okay, so let's say you're going to invest your money for 12 years, $100 every month. All right, so K is of course 12 in both of these cases because it's monthly. And so R is different, right? So here for 20 years, so T is 20. How much money are you going to have? The sum after 20 years is going to be 100, and then 1 plus 0.06 divided by 12. Raise it to the 12 times 20, and that is 240 payments, minus 1, all over the rate per period, right? I'm not going to repeat, I'm not going to show you how to do this. You have seen this before. This part becomes 1.005. Raise it to the 240th power, subtract 1 from it, and then divide that by 0.005. You multiply that by 100, and you will end up with $46,000, $46,204.09. Not a bad investment plan. $100 a day for a long, $100 a month for a long period of time at the rate of 6% is going to yield you over $46,000. If you can find a plan where the interest rate is 7%, the formula is pretty much the same, except you replace 0.06 with 0.07. And unfortunately, that number, the number inside is going to be ugly because 7 is not such a nice number. But everything else stays the same. Okay, so if you do that, and maybe I will show you how to do that, you'll end up with $52,092.67, right? So the difference here is about $6,000, okay? And that's the difference that this 1% makes, a 1% difference in the interest rate makes, right? So don't take that interest rate casually, take it very seriously, okay? Because over a long period of time, that small and minute difference in interest rate could end up rather significant. Okay, so let me just show you how to do this last part here, and then we will conclude this section. All right, so how do you do that last thing? 0.07 divided by 12 equals, add 1 equals. All right, so that is the value inside the parentheses. You raise it to the power of 240. Okay, so that's, again, a strange number. Subtract 1 from it. Make sure you hit the equal sign to find what the numerator is. And then you divide it by what? Okay, divide by parentheses 0.07 divided by 12. That number, which is too ugly to enter. Okay, this is a denominator. And when you click equals, then that's going to give you everything that is not the 100. Okay, so now you're ready to multiply this by $100 a month, and this would give you the answer, $52,092.67. Okay, so hopefully you have learned how to do this on your calculator, and now you should be able to, hold on a second. Okay, so now you should be able to struggle with and complete these questions on the next page. All right, make sure you show your work, use your calculator, and once you have your answers, you can go online to the online quiz section 3.3 and complete that. You remember you have up to 3 attempts, and only the best score will remain in the grade book. So have fun and get familiar with annuities and other savings, because the compound interest power is going to work for you if you save money. Next time, we will study section 4, where we find out that the compound interest power will work against you if you borrow money. Until then, I hope you have a great day and see you later.